Hi, it's Dr. Andrew Edwards from the Darwin Centre for Bushfire Research, part of REAL, and here at CDU. I'm here giving the second tutorial, week 2, for ENV318. I've just given a lecture to you this morning looking at satellite imagery and how we'd use the different types of satellite imagery to create fire history. And from that we've derived a whole lot of fire metrics, and we use them in a whole lot of ecological analyses, sort of evaluation, monitoring and assessment of fire regimes using various models to look at ecological processes. So what we're going to do in this exercise is download a national data set called the Interim Biogeographical Regionalisation of Australia. It has a bunch of regions and sub-regions that represent biomes that are significant and unique at a particular scale. And it's a national data set. It's a bit coarser for Central Australia and North Australia than it is in Southeast and Southwest. You can have a look at that data set when you download it yourself to confirm what it is. So just go to the internet and go to this web page called Australia's Bioregions Maps, and then you can click on this link down here about downloading the data sets. There are a bunch of PDF files, so you can see this map here on the screen. It's fairly coarse, that's at sort of a high level, and then there are much deeper refined levels, not so much in our part of the world. Then click on this link down here called download the data sets and go and select that, and they'll come up like this. So here's a list of the data sets that are available. You can see there's versions 5 and 6, and they're much older and they've been refined over the years, mostly to just cut up some of the regions into smaller sub-regions in southeast and southwestern Australia. It hasn't really affected our part of the world, hardly at all, in fact. So the data set I'd like you to use is this version 7, sub-regions, states and territories. It's sort of the finest one available, and it's pretty good if you have a look around. So you click on that and you end up at this. Actually, let me just show you. You click on that and it'll take you to a download area, and then you end up going to this area and you get to click download data, and that'll bring down a zip file, and that goes into, in my case, it goes down into this downloads folder, and it's here, IBRA 7 subregions. So we're going to do our analysis in the various subregions, and do some comparisons of them. But what we also need are these 3 NAFI fire histories. So if you haven't already downloaded them, again, go to NAFI, go to data, select data, and then select fire history 2000 to 2020, and grab the 3 shapefiles. If you just click on that link shapefile, it'll start to download them. See, I've got them downloaded here already in preparation. So they go into my downloads folder, so I'm just going to work from there to make it easy for everybody to see what's going on. All 4 of these files are zipped. You have to unzip them. So I've got 7-zip on my machine. I'll just go 7-zip, extract here. So I've done that to the 4 files, and they are down here somewhere. There they all are. So you can see the time since last burnt, 0020. That's 21 years of time since last burnt information. So that'll have values going from 1 back to 21. 1 meaning areas that are mapped were burnt last year. 2 means 2 years ago. 3 and so on. And then the fire frequency 00 to 20, that's the number of times every point in the landscape has been burnt in 21 years. And FFL, frequency late, is the frequency of late dry season fires, which we refer to as wildfires, for the last 21 years again. So I just grabbed those 3 layers, the IBRA layer, and I add them into ArcGIS Pro, which I've already done. You pause the video now and do yourself. So, and then what I've done is I've coloured the different IBRAs up in different colours, and I've labelled it so that you can see. And the label I've used is this one here, subname 7. So there's the table open, and you can see desert and a whole lot of others. So let's see. Okay, so we're going to be looking at doing. So what these layers of, if you try and display one of these layers of time since burnt or fire frequency, you'll see that they're absolutely massive, millions and millions of records in them. So we're going to just analyze a subset area in this first instance, and we might do a few different subsetted areas by way of comparison. So what we'll do is we'll get the select tool, and I'll just select Coburg for now. There we are. To keep it small to start with, just so you can actually see how much data there is. So what I want to do is an intersect. So in the analysis toolbar, I select intersect, and in the geoprocessing window, I get this output here. So I'll call it by default it called it intersect, but I've already made one as practice before, so I'll call it intersect. Got something you guys can see. Right, we want all the attributes from both tables, so all the attributes from the EEDWRS, which we don't really need, we really just need this subname one, and we need the attributes from the fire history. If we look at any of those fire histories, you'll see they'll have an attribute called grid code, which is the number of times whatever the phenomena has happened, and obviously the other thing we need to calculate is area, but we'll do that with the later data set. So we've got this set up, this intersect, and I'll just run that. If you run yours at the same time, we'll hopefully finish at the same time. If not, you can pause. I'll wait for you. And I like to have a look at the details, process, steps that are happening, messages, make sure moving along hunky-dory. Okay, no errors or warnings. Nothing happening. Alrighty, so you can see it's reading the number of features. So it'll be reading the whole fire frequency data set, which is many millions of records. Now 3.5. Should be relatively quick. And did this for the first time. I did it for like about half the Northern Territory, selecting half the EEDWRS for Northern Territory, and it selected 1.5 million records, and it took 9 minutes to process. Hence, another reason why one like Coburg, when you've got more time, you can. Oh, there we go. We're going through all the steps. So saying it's complete. That's excellent. That took just over a minute. That's great. Okay, so now we've got our intersected file. I'll just turn the EEDWRS off. Turn that on. Let's see. There we are. So it appeared there on the screen nicely. I will have a look at that attribute table. And you can see it's still got 12,500 records. You can see the data, even though we're looking at a really small subset, it's got a lot of data. Now we want to calculate area. Generally, you find they've added area to these things, but it's calculated in flat and long, which is completely wrong and erroneous. Generally, if we click on, it won't let us recalculate the geometry of some of these fields. So we'll just add a new field and calculate the area. So let's call it area. Let's make it double data type. The number format is numeric, of course. Numeric. Okay, and then that'll be that. So we'll right click, mask and save, find changes. So we should have added that new field to the table. Go to the table, there it is. And we'll calculate the geometry on that. The other thing I've done just before I do this, I have gone and changed, you may or may not have to do this, but as a matter of course, it's a habit, I've changed the coordinate system of the whole map to WGS 1984 UTM Zone 53. UTM is a Mercator projection, so it's a metric, which is very handy. That sits under Southern Hemisphere, and WGS 84 under UTM. So you'll find UTM at the base under projected coordinate systems, and then you'll find WGS 84 at the bottom of that. So that's sort of the world version of everything. And obviously we're in the Southern Hemisphere. And Zone 53 covers the eastern 2/3 of the Northern Territory, so it still works out quite well for calculations. I would normally use a AEdwards projection for anything that I'm doing in Australia, but I noticed it's not in here as a standard, so I didn't use it for this class. Cancel that because I've already done it. Okay, so let's go away and calculate the geometry of that area field. The property we want is area, obviously. Area unit, we'll just do it in square kilometres. And the coordinate system is the current map, which will be UTM Zone 53. Excellent. So if we hit OK, that should go off and calculate square kilometres for all of the records in Coburg. It has. Excellent. Okay. So now the next thing we want to do is copy this data into Excel. What I tend to do is, because nothing's selected at the moment, is hit switch, and that'll select everything. And then we can just hit copy, and that just chucks it into the clipboard. Too long. There we go. 12. When I did the 1.5 million records before, it took about 3 minutes. So be careful. And then we can open up Excel. I've just got an empty worksheet here. If you want to pause the video now so you can go and open Excel and open an empty workbook. So we've got the data in the clipboard, and we just hit, I just hit Control V or hit paste and put the data in. So you can see the whole table's there. We don't need most of these things. We don't need the ID, the shape, the FID, the ID. We do need grid code. We'll keep that one. We don't need that or that. We know it's in the ET. That's not of use to us for our calculations. We know the subname is Coburg. We want to keep that. And then these other fields telling us more things about the Coburg. You know, the different, a lot of fields that have mostly done it. 2616 is obviously the total area of that Coburg polygon area. So to check that we've got all the data, what we could do is go to bottom of the data set, our area field, and hit auto sum Jingo 2616. So that's great. Looks like we've done our area calculations correct. So I might just get rid of these other fields that we don't need, all the way up to area. Really the only three we need this bit of analysis. So grid code is representing biofrequency. Subname is the area. We're looking at Coburg, and then we've got the area of each polygon. So I use a lot of these analyses in the pivot table. If you're not familiar with it, you make yourself very familiar with pivot tables. They are your best friend in data analysis. Brings up this window. You can see it's automatically selected all data set. Sometimes you might have to select for what you're doing, but it's pretty good data. And you can throw it into a new worksheet, or you can use an existing worksheet, and it'll ask you where do you put it. So I'm going to put it here. Here our data set, just so we can see it. Nice to work with. And you get this pivot table field window over here to the right. And the thing we want to know about is the grid code. So put that in the rows. You can see there. You can play around with these. You can do all sorts of things. I could have put it over here, and then it goes across that way. And of course, so we want to sum the area. So that's in our little sum box there. You can see it's a bit harder to read, so I might put this back over in the rows. So I can, and there you go. So So there's our data summarized from that really big table. So you can imagine if we had other sub-names in there, so we had 3 or 4 or 5 of them, separate, we could add that field into the table here, like that. It's there above it, so it's St. Coburg, and then it would do the same thing for Darwin Coastal and the other ones that are there. So you'd have all your data nicely summarized. We don't need sub-name, but let's put it there anyway. So the first thing I want to do is, just so we can use the data to make a table, it's easier to sometimes just sort of kind of copy it out. So let's call that first value unburnt, and then the others are all the same. So I'll make this equal to that field and copy them all down. And then the other thing I'd like to do is make it a percentage of total. So that would be equal to this number divided by the total, and I'll hit F4. F4 allows you to cycle through, the dollar signs in front of the column heading and the row heading. If you put a dollar, it makes it stay there when you copy and paste it into other places, so it's handy. If you hit F4 again, it makes the G soft and the 25 hard, and then it makes the G hard, the 25 soft, and then 2 more times and you're back to the whole lot. So that'll just always reference that cell. So you see now, if I copy, hang on, I'll times by 100 to make it a percentage. So there we are. So 10% of the region was unburnt in 21 years. Probably mangroves, I guess. And then see if I copy that down into the rest of the fields, you can see that that $G, $25 has stayed, and so it's always referencing. If I hit F2, it shows you where it's referencing. That's referencing that cell there and that cell there. And you'll see if I hit F2 in any of these records, it'll always do that because of the dollars. That's a very handy tool, the dollar signs. So now we've got a nice simple table, and I want to turn that into a graph. So I'm going to select this column of the data and create a graph, just a column graph, and there we are. So this is, change the title to Coburg Fire Frequency 2020. There we go. So now we've just done a very nice bit of analysis. We want to actually make those labels match those labels up there, so we get select data, and that's the data set listed there called Series 1. If I'd have put a label on the top there, it would have called it that. And then we'll edit this. It's just given it an arbitrary number from 1 to 21 because there's 21 pieces of data in there. So I'll just select as the label. Okay, and there we go. Click OK. So we can see quite clearly now what our data are doing. So you can see that majority of the, half the data sit between, about 9 and 14. So I mean, you're sort of guessing that it's burnt, on an average, it's probably coming out at about 11, which is nearly every second year. So that region is experiencing fire every second year. So there's your analysis. So what I would like you to do is exactly what I've done here. Do it for 2 or 3 of the IBRA sub-regions. Go back to here and look at them. I would select some more small ones. So maybe go for Merganella, maybe go for Nhulunbuy. I did Darwin Coastal before, and it was still about 140,000 records. You can do Darwin Coastal if you wish, but you should do that for each of the 3 fire layers and for at least 3 of the IBRAs, and then put it into a Word document and write some words about what you're seeing, what's happening. And I think you should then send it to me, and we'll test and see that you've done all this work. Okay, thank you very much and good luck. If you've got any questions at all, you can email me. It's andrew.edwards@cdu.edu.au. Yeah, good luck. Pretty simple. Thanks.